Good morning everyone. Let's solve a problem on tolerance for the hole and shaft. Determine the tolerance on the hole and shaft for a precision running fit designated by 50H7G6. State the actual maximum and minimum size of the hole and shaft and maximum and minimum clearance. So this is a problem for designing the hole and shaft pair, and they have given 50H7G6. That means you are going to design a pair of hole and shaft of having dimension 50 and tolerance H7 and G6. Let us look into the procedure how we are going to solve the problem. First, it is given 50 mm diameter. Lies in a standard diameter of 30 into 50. Now in the question they have given 50 mm diameter. There is a table for a diameter step. In this table we can see here 50 mm lies in 30 and 50. Here 30 and 50. So we are going to select this dimension. Then how we are going to calculate the problem? From the formula, general formula, we take root of 30 into 50. So this 50 mm lies exactly on this point 30 and 50, and it also have a small value at 50 and 80. But since there is 15 number is available in both the set, we are going to always select the lower one. 30-50 is preferred. So from taking this value, we take d equals root of 30 into 50. That is, we get 38.73 mm. So this d value is used for calculation of all the tolerance, etc., whereas the 50 mm d is used later. Going to the fundamental tolerance formula, IT equals I in micron, that is equals 0.45 cube root of t plus 0.001 d. Substituting d equals 38.73 mm in the formula as shown, we get as I equals 1.5612 micron. Remember, it is given in micron, so our answer will come in microns only. Then coming to another table, there is two parameters given in the question, that is H7 and G6, and we are going to solve one by one. Capital letter is for the hole and small letter is for the shaft. So first we are going to take hole design. Now in the hole design they are given H7, so you can split the problem into two parts. First part is 7, the number 7 for a hole quality 7. What does it indicate? This quality 7 means it is a fundamental tolerance of IT7. Fundamental tolerance IT7 is shown here. You can see here IT7 is given as 16i. So 16i or 16i, where I is already calculated, you have to substitute from the previous calculation. And remember, your answer will be in micron itself. You get 16 into 1.561 2 microns, or you can write it as 0.025 mm. It's already converted, because since our all dimension will be mm, later it will be easy for substitution, so I have converted into mm. Next we will go for H hole. Now H hole, there is a graph for different parameter alphabet, and in H hole we have fundamental deviation always taken as 0. So there is no value for the fundamental deviation. That means the shaft lies on the basic line. Therefore, the hole limits. Lower limit is nothing but you are having the same value which is given in the question plus the fundamental deviation. You get the 50 mm answer. Whereas upper limit is lower limit plus the fundamental tolerance, or we can write it as 50 plus 0, that is previous answer, plus fundamental tolerance. You get the answer 50.025 mm. And once you have done this calculation, we will draw a diagram. And they have given to calculate maximum minimum tolerance, plus optional we can calculate hole tolerance. Hole tolerance is nothing but difference between upper and lower limit, which it gives 0.025 mm. And finally diagram for the hole. I can see here 50 mm is a basic hole. We have mentioned it. Since there is no fundamental deviation for the H hole, the entire diagram lies on the basic line, on the straight line, and from there we are going to have a small tolerance of 25 micron or 0.025 mm, and the lower part will be the lower limit and upper part will be the upper limit. Coming to the next part, that is shaft design. Now in the shaft design they have given G6. So what does it mean? First we will go 6. For a shaft quality 6, it is given as fundamental tolerance from the table is 10i. In the same table which is got from the previous one. For G6, 6 it is 10i. When you substitute it, we get 10 into 1.5612 micron equal 0.0156 mm. Then for G shaft from the table, there is a table for tolerance. It will be most of the time given in the question. I have not mentioned here. For G shaft, it is given as minus 2.5 d to the power of 0.34. Substituting d here, d is 38. Don't substitute 50. It should be 38. For all the deviation tolerance, we are going to use the step 1 answer. For the final answer only, we are going to use 50. So you will get the answer as minus 8.667 micron. Remember, there is a minus symbol. You have to be careful with this one. And the answer is in micron, or you can convert into mm. Then the shaft limit. Now here lower limit. We will be going in the negative direction. In the shaft direction we went in the positive direction, upward. Now we will go in the negative direction. First lower limit will be the basic 50 mm minus the fundamental deviation. We will go to 49.5. You are going in the downward direction. For upper limit, further we will reduce from the lower limit, that is 50.05 minus 0.01, that was the fundamental tolerance, and we are having the fundamental deviation. Or in other words, lower limit minus the fundamental tolerance will be the upper limit, still further. And difference between the upper and lower limit will give the shaft tolerance. So this is a diagram. If you look at the diagram, it was a basic line of 50 mm. This is the line of 50. Then we are going, because there is a fundamental deviation, it is rounded off here, we are going a little bit downwards. Then you have a first value, which is nothing but a lower limit. Then further if you go downwards, we get upper limit. Actually upper limit is mentioned above, lower limit is below, but since it will be confusion between the shaft and hole, we are taking in the hole diagram, we are taking one direction. In the shaft diagram, we are taking in another direction. Further, they again calculate the maximum and minimum clearance. So maximum clearance will be maximum hole and minimum shaft, whereas minimum clearance will be minimum hole and maximum shaft. Or we get 0.0125 maximum clearance and 0.01023 mm as a minimum clearance. Hope you have understood. Thank you.